let's talk about reference angles because we will need to use them later on when we do various trig problems. Reference angles, actually, I hope you will not find them very difficult. We're going to look at reference angles, both looking at measuring angles in degrees and then radians. We'll do degrees first, and we'll figure out some reference angles, then we'll turn around and do some problems in radians. So here's the idea of reference angle. Let's go ahead and draw our traditional sort of X and Y axes. And of course our terminal side is almost always the x-axis. I'm going to draw an angle here, just sort of some random angle, like in the first quadrant. And I'll call this theta, like we normally do. Now let me give you the definition of a reference angle, and it may not make sense quite at first, but when we do some examples, hopefully it'll become pretty clear. A reference angle the smallest angle back to the x-axis. All right, the smallest angle back to the x-axis. What in the world does that mean? Let's do some examples up here just by looking at the picture. If that's my angle, and I'm asking for the reference angle, that little r stands for reference angle. I take my angle and I say, what's the shortest distance, what's the smallest angle to get to the x-axis? Either positive x-axis or negative x-axis. Well, this one's pretty obvious because from here to here, the shortest distance back to the x-axis is right here. So as it turns out for this example, the reference angle is actually my original angle. Now let me say right now, the reference angles are not positive or negative. Well, reference angles are always positive. You don't have a negative reference angle. So even though when I drew this picture, I sort of drew my angle almost like with a negative arrow, reference angles are always positive. You're just looking for the shortest distance, the shortest, quickest way back to the x-axis. Let's do another one, and then you'll sort of see more clearly. Let's go over here in the second quadrant. So there's my original angle, and we're asked to find the reference angle. Well, the reference angle, you go to your terminal side of your angle, and from there you say, what's the shortest distance, the quickest way to the x-axis? Well, in this case, the shortest angle, smallest angle, quickest way back to the x-axis is to go from here over here to the negative x-axis, and this becomes my reference angle. So this is my original angle, but this is the reference angle. Now in a minute we'll actually use some numbers, but I just want you to visualize what's going on. Let's do another one. How about if I go and draw an angle in the third quadrant? Say this is my angle right here. Now I want to find the reference angle for this angle. Once again, what do? I go to the terminal side of my angle and try and find the shortest distance to the x-axis. Would I go here? No, I would not. The shortest distance is right here. So that becomes my reference angle. And just for fun, we'll just do one more, maybe an angle in the fourth quadrant. So say my angle's right here. So there's my angle all the way around here. But now I say, what's the reference angle? Well, shortest, quickest way back to the x-axis is right here. So that's my reference angle. So now based upon this, hopefully now you can visualize what our reference angle is. Now let's actually do some calculations. So what we will do is we'll actually take an angle in degrees and we'll ask to find the reference angle. So say we were given an angle of 100 degrees and we're asked to find the reference angle. Just to start with, let's go ahead and sketch this out. I don't think we'll do this for all the examples, but just once again so you can visualize it. A 100-degree angle, 90 degrees is the y-axis, so 100 degrees just must be a little bit past So there's our 100-degree angle. And now we're asked for the reference angle. Well, the reference angle, the shortest distance to the x-axis, is going to be right here. Now some of you, just in your head, you might know what the reference angle is. But let's do it mathematically. If I know the total distance, if I start at my positive x-axis and go all the way to the other side, how many degrees is that? 180 degrees. So if I know from here to here, it's 180 degrees, and this is my reference angle. Hopefully you can see that if I take 180 degrees minus 100 degrees, so 180, the whole distance, minus 100 degrees, my original angle, that should leave the reference angle. So in this case, I can say the reference angle is 180 degrees minus my original angle, which means my reference angle is 80 degrees. How about I have a 215-degree angle, and I want to find the reference angle. Actually, it's a little bit of a pain, but it really never hurts to draw the angle because then you can make sure you're not making a mistake. So 215, well, I know 180 degrees is to the negative x-axis, so it must be around 35 degrees past it, so it might be maybe right here. So that might be a 215-degree angle. So first of all, what's my reference angle going to be? Well, it's going to be this angle right here. Now, how could we mathematically figure out that reference angle? Well, hopefully common sense says if I take the whole angle, 215, and then I subtract 180 degrees, then that should leave the reference angle, right? So in this case, it'd be 215 degrees minus 180 degrees. Looks like the reference angle is 35 degrees. How about if I had an angle of 45 degrees. Well, here's a case where the reference angle is going to be the same as the original angle. And that's going to happen if your angle's in the first quadrant. Now, just for fun, hopefully you're getting this now, let's add a little complicating factor. How about if I say I've got a 400-degree angle, and I want to know what the reference angle is. Let's go ahead and try and draw out this 400-degree angle. Hopefully you're already realizing that one trip around the circle is how many degrees? It's 360 degrees. So a 400-degree angle must mean you go one trip around the circle, and then you go 40 degrees more past the x-axis. So in other words, if I start here, if I stop there, I've gone 360 degrees, but I need to go 40 degrees more, so maybe it's going to end up about right here. So that's a 400-degree angle. Now, according to this graph, where would the reference angle be? Shortest distance back to the x-axis. And how would it be mathematically? Well, how about 400 degrees minus 360, right? 360 takes me here. Now, a lot of these, you can just visualize the answer in your head. You don't have to necessarily write this out. But just in case you're a little confused, that's the way. Let's do one more of these. All right, this one will be fun. How about all right. For a negative 650-degree angle, what would the reference angle be? So let's draw a 650-degree angle. So now it's a negative angle, so I'm going to go sort of in the clockwise direction, and all the way around the circle, that right there is negative 360. Now what if I were to go 2 trips around the circle? What would that be? Well, it'd be negative 360 more, so it'd be negative 720. So I can see that my angle is somewhere between 1 trip around and 2 trips around. So basically, I'm actually going to grab my calculator, because basically 1 trip around is 360, and how much more do I have to go to get to 650? I actually have to go 290 degrees more. So I'm sitting right here at negative 360. I know negative 270 takes me to the positive y-axis, and I need to go 20 degrees more so it's probably maybe right in here. So that is a negative 650-degree angle, right? So 1 trip around the circle's negative 360. I go 290 degrees more, and I get to negative 650. All right, that's interesting. But now, The point of this problem was to find the reference angle, which I know is going to be this distance right there. So hopefully, from what we just showed, we know that little angle there is 20 degrees because we went 20 degrees past, because 290 degrees more, 270 degrees is here, and 20 degrees past. So therefore, hopefully all of you can see that the reference angle would be 70 degrees. And once again, reference angles are always positive degrees. All right, so that's the idea. Now let's do some reference angles in radians. So now it might get a little complicated just because we have to work with radians. So let's say we have a (3π/4) angle, and we're asked what is the reference angle. So now you have to remember, let's just review 0 radians here. The y-axis, that's considered π/2 radians. The negative x-axis is pi. Down here is 3π/2. And when I get back to my x-axis, one trip around, I've gone 2 pi radians. So 3π/4 actually is halfway in between pi and π/2. So this is my 3π/4 angle. Reference angle would be here. Hopefully you can see that the reference angle would be pi minus 3π/4. So actually this reference angle is pi/4. Let's go to, how about, let's go look at an 11π/6 angle. See if we can figure out the reference angle. So 11π/6 this is where you have to be able to start work with fractions. You know, one trip around the unit circle is 2 pi. However, if I try and rewrite 2 pi with a denominator of 6, that would be 12π/6, right? 12π/6. 12/6 is the same thing as 2. So 11π/6 means it's just a little bit short of the original y-axis. So this angle right here would be 11π/6. So what's my reference angle? It's that right there. Mathematically, I would say my reference angle should be 2 pi minus 11π/6, right? 2 pi is one trip around the circle, and I subtract out the 11π/6, and that should leave my reference angle. So mathematically, I'm going to change 2 pi to 12π/6 minus 11π/6. Turns out that reference angle would be pi/6. Let's do a couple more. Let me go over here. How about If I say my angle is 5 pi, no, I don't want to do that. Let's say, sorry. I'm actually sort of making these up as I go. Let's say, let's say my angle is 7 pi over 3, and I want to know the reference angle. Let's see if we can figure out what 7 pi over 3 looks like. Now the first thing I ask myself is 7 pi over 3, is that more than one trip around the circle? And the only way to know that for sure is, you know, one trip around the circle is 2 pi. Now if I want to write this with the denominator of 3, multiplied by 3 over 3, 2 pi is the same thing as 6 pi over 3. And my angle is 7 pi over 3, so I know actually this angle is one trip around the circle, which is 2 pi, and then you go pi over 3 more. 2 pi is 6 pi over 3, I'm at 7 pi over 3, so it must be something like this. So then what would my reference angle be? Well, it's sort of hard to see, but basically, shortest distance back to the x-axis. And how could I figure this out mathematically? Well, it's a couple ways. I know one trip around this circle is 6 pi over 3. I'm at 7 pi over 3. So you could say 7 pi over 3 minus 6 pi over 3. The reference angle is pi over 3. All right, reference angles, not too difficult, but they become important as we go on with these trig problems.